All right, welcome to DellyMaths Concepts, everybody. Please like, share, and drop a comment here, all right, at this video. All right, I'll be right back with you. All right, so the first question here, it says we have 1 4/7, and we're going to divide this by 2/3, then we subtract 1 5/7. So I'm just going to change all my mixed numbers to improper fractions. So 7/1/7 plus 4, that's going to give me 11/7. That is going to be divided by 2/3. I'm just going to change everything. 7/1/7 plus 5, that's going to give me 12/7. I'm going to work out this part right now. So when we divide, we normally change the division to multiplication, and then we're going to reciprocate the fraction that comes at the back. So this is 3/2. If there isn't anything that can be canceled, like right now, this is 33/14, meaning 11 times 3 and then 7 times 2. We're going to subtract 12/7. The LCM is 14. 14 into itself is 1. 1 times 33. That's 33 minus 7 into 14, 2. 2 times 12, that's 24. So when we subtract this, we're going to end up with 9/14. And that's the answer. So if you don't know to put this on your calculator to get the answer straight, that's a procedural way to get it done. Let's take a look at question 1B. It says, when Megan started working, she was paid $85 each week. After a 6-month probational period, her pay increased by 20%. How much was she paid each week after? All right, so this is after the 20% raise. All right, so basically there has been an increase. So we want to establish the fact that there has been an increase of 20%. So there are more than one ways we could work out this, right? There are more than one ways we can work on this. If there is an increase of 20%, it simply means that we went up to 120, right? Because there is an increase. So we could find 120% of 85 and it takes us there. And that's one approach. So let us look on this approach here. So 120% is 120 over 100. And if we multiply this by 85, we'll get the answer right now. That is going to give us a total of $102. For some of us, if we don't like working it like that, you can find your 20%. So I'm giving us a second way of solving this. You can find 20% off the $85. And 20% of the $85 is going to be $17. And then we could add that 85 plus the 17, and that is still going to take us to 102, just the same. So it's all about how you feel and when you're working the problems, right? All right, let's take a look. In 1965, the population of country A was 2,714,000. In 2014, the population was 3,363,900. Write the population of 2005 correct to 3 significant figures. So 2015 should say, here it is. So we want to write this correct to 3 significant figures. Remember, all digits are significant except 0, which may or may not. So the third significant figure right now is actually this number 6. And then what we're going to do is to look at the digit next door. If that digit is less than 5, the spot remains. Therefore, it's going to remain at 3, 6, 6, and then everything else becomes 0. So we're looking at 3,660,000. And that is to 3 significant figures. Context. Let's take a look at the B part. It says, write the population in 1965 in standard form. So let's go for the population in 1965. In 1965, we have 27145. No, there's no 5. 14 0, 0, 0. So that is the population in 2000 and in 1965, should say. All right, so they want this in standard form. In standard form, the framework is that you're going to have the decimal point after the first non-zero digit from left to right. So we're looking at that. All right, we're looking at that. That's the basic framework. And if you want to keep your zeros, I'm just saying that's the idea. So we're going to get this here, and it's going to be times 10 raised to some power. Remember, when you do not see the decimal point, it's at the back. So let us check how many places it would have moved. So it moved 1, 2, 3, 4, 5, 6. So it moves 6 places to get there. So basically, this is 2.714000 times 10 raised to the 6th power. All right, so we got that. Now let us take a look at the other question. It says, determine the percentage increase in the population from 1965 to 2050. So what we want to do is to take a look at what happened. So when we deal with percentage increase, right? Percentage increase is actually dealing with the increase. So we're talking about 3, 6, 6, 3, 9, 0, 0. And you're going to take out what it was. And you want to divide this by the original thing, what it was. All right, so when we subtract that and work it out and divide it by this, remember that this is going to percent, so we're going to multiply this by 100 over 1 or 100. Take your time on your calculator. We get 35%, right? So that's a 35% increase. Let's take a look at the part D. Part D says that the ratio of teachers, so we're looking at the idea of teachers to male to female. So it was given, so this is T, this is M, and this is F in terms of the numbers. If the total number of students is 630, determine the number of teachers. So if I'm going to deal with the number of students, right, I'm going to have to look at the proportional part that is allotted to students, which would have been just this part here. So we have to pay attention. The 17 plus the 18 would be dealing with students only. This is for students. The other part was for teachers. So then we can look at this and use it to solve the problem, right? Because we are saying that 3, which is 35 parts, is linked to 630 persons. So if we should divide this by 35, we're going to get 1 part. That's about 18. Now we're going to use this to multiply, right? We can use this to multiply by how many teachers. So the parts for teachers would be 3. So the number of teachers will simply be that 18, which represent 1 part, times the 3 proportional parts for teachers, and we're going to get about 54 teachers here. Let's look at the second question. A typical number 2 question looks like this. It says 2 quantities, n and t, are selected as follows. N is equal to the square root of t. Find the value of n when t is 49. I'm supposed to find the value of n when t is 49. So I'm going to replace that t with 49. So what I'm looking at here is, I'm looking at n is equal to plus or minus 7. But So in context here, we're saying n is equal to 7 or negative 7. Make t the subject of the formula. Now let's look back at it. N is equal to the square root of t. So what we're going to do is we're going to square both sides because the square and the square root cancels. So n squared is equal to t. So you could say t is definitely n squared. All right, let's take a look. It says Ali is X years, Jim is 5 years older than Ali, and Chris is twice as old as Ali. Okay, so you're seeing Chris twice as old as Ali, Jim 5 years older than Ali. Jim's age is what, right? So remember, Ali's X. So Jim will be X plus 5 because he's just 5 years older. What is Chris' age? Chris is twice as Ali, so it's going to be 2 times X, which is just X. Now, let's take a look at what they want. They said in 2 years' time, the product of Ali's age and Chris' age will be the same as the square of Jim's present age. All right? So take a look. Let's set it out. Ali is X years old. Jim is X plus 5 right now. And Chris is 2 times that. All right. So let's take a look at the idea. So this is currently what's going on. So in 2 years, everything will switch up, right? In 2 years, we're talking about Ali. Ali is going to be X plus 2. Jim is going to be X plus 7. Chris is going to be 2X plus 2 because we're referring to 2 years from what they are now, right? So let's take a look at what they want. They're saying in 2 years' time, right? In 2 years' time, the product of, to watch this, the product of Ali and Chris. Ali and Chris. Ali and Chris. The product of their age, so that's Ali's and Chris' age, is going to equal to the square of Jim. So we're talking about Jim's present age, not Jim's 2 years down the line age. So we're using this for Jim because this is Jim 2 years down the line, right? So what they're saying, 2 years from now, the product of Ali and Chris is Jim's square. So that's what we're working with. Let us do our quick filing here. We're going to use X to multiply by the 2, then X times the 2X, and then X times the 2. And then we're going to go 2 times 2X and then 2 times 4. So let us go. X times 2X is going to give us 2X to the second. X times 2 will give us 2X. 2 times 2X is going to give me 4X. And 2 times 2 will give me 4. So I'm looking at that on my left side. On my right side, though, when I square X plus 5, it's really X plus 5 times X plus 5. There are multiple ways to do it, but one of the simplest, well, I won't say simple, one of the regular procedural way is that you could file it out, right? So you could file it out. So if I file it out, X times X will give me X squared. X times 5 is going to give me 5X. 5 times X is going to give me 5X. 5 times 5 is going to give me 25. So I'm going to put this here. X squared plus I'm going to add this up. That's 10x plus 25. I'll say to you that there's a very easy way to square binomials is this. You square the first term, which is this x squared, so it would have led to x squared. If you square the last term, it's going to lead to 25. And if you multiply these and double it, 5x double give you 10x. So that's a quick way of we can do it at times if you don't want to go through the long procedure. But anyways, we're looking at this. Let us simplify this because remember what we want to prove. So we're looking at 2x squared plus 6x plus 4. And now I'm just gonna work some stuff for you. So I'm gonna subtract x squared. I'm gonna subtract 10x. I'm gonna subtract 25. So you could see that there's a 0 here. When I do that, the x squared would have to subtract from this side, the 10x would have to subtract from this side, and 25 from this side. So when I simplify this, I'm gonna have x squared minus 4x minus 21. And this is equal to 0, which is what they ask us to prove. All right. So there it is. We actually prove that. And there are diverse approaches to the problem. But anyways, that's that. That's for 3 marks. Let's take a look. Calculate Ali's present age. Bear in mind, Ali's age is x. All right. Remember, we're told that Ali's age is x. So we're going right there. We're going back to basics where x squared minus 4x minus 21 is equal to 0. If I factorize this, well, this could be factorized easily, but I'm going to walk you through it. AC is going to be 1 times negative 21, which is negative 21. The numbers I'm going to be using, though, will be 3 and 7. It's going to be a positive 3 and a minus 7. So let us just put it through. So we're talking about negative 7 plus 3x minus 21 equals 0. If you're wondering if we should put the 7 first or the 3, it doesn't matter. The main thing is that we want to make sure that we have a negative 7 and a positive 3. And this is the reason why. Positive 3 times negative 7 is negative 21. Positive 3 minus 7 is minus 4. So this is my AC and this is my B. And so you know that we're good. Let's factorize by grouping here. X is my common factor. X into x squared, that is x. X into negative 7x, that's negative 7. Here I'm going to use positive 3 into 3x, that is x. Positive 3 into negative 21, that's negative 7, and this is equal to 0. So I have my common factor, x minus 7, and then we have x plus 3. This is equal to 0. Now, when you solve this, you're going to realize that either x minus 7 is 0, which means that x is equal to 7, or x plus 3 equals 0, which means x is equal to negative 3. And as you could see, your age cannot be negative. So this is not viable in context. So that this is not viable. So we have to conclude that Ali is 7. Because remember now, you have to bear in mind that you can't have a negative age. So the negative 3 is not viable for a context right now. So 7 is the answer. Let's take a look at what a normal, typical number 3 question looks like. It says, the diagram below shows the triangle PQR in which angles QPR is 62, angle PQR is 90, and we have 11, which is PR. All right. So what they want us to do here is to calculate the size of the angle PRQ. PRQ. They want this angle. Normally, I would say mark the angle first and take a look. Now we have, this is 90 here, bear in mind. A triangle has a total of 180 degrees internally. So what we're going to do is to take the sum of 62 and 90, and we're going to take that from 180. So basically, taking 152 from that. So we're left with about 28 degrees. So this is 28 degrees right there. And that is that angle. Let's keep rolling. The length, so we're looking at the length of R. So you're looking at the length of RQ. RQ. So if you take a look at RQ, we're trying to find the length of this side here. Well, you can do this a number of ways. I'm just going to zoom in onto one. So I'm going to use, let us say, I'm going to use sine. So if I'm going to use sine, I'm focusing on this angle here, and it's going to deal with the opposite side over the hypotenuse side. So then, so the sine of 62, so the sine of the 62 degrees is going to equal to RQ over 11. Bear in mind though that we could have done a number of things, because so ka tower is what we're using. So I'm using this from 62 degrees. I could have used 28 degrees and then I would use that, right? And if I and that's it. Nothing else could work at the moment unless we're gonna do extra work. So I'm just taking it from the sine angle. So I'm gonna multiply both sides by 11. So basically on my calculator, if I put 11, if I just put 11 sine 62, it's gonna give me the length of RQ, right? So 11 sine 62 is gonna give me about 9.71. So RQ is equal to 9.71 centimeters. There you go. All right, let's see what else they want from us. All right, there's a B part to the question. Let me minimize this so I could have a good visual. So the question says, the diagram below shows the three triangles, X, Y, and Z. We're seeing that on a square grid. All right, what's the first question? The first question says, triangle X is mapped onto triangle Y by a reflection, and we want to state the equation of the mirror line. All right, so they want us to state the mirror line. So again, we're focusing on X onto Y. All right, so you're looking at X onto Y. So here are the triangles that we're looking at. You're looking at this triangle here, X, Y. The mirror line. The mirror line is equidistant between corresponding points. So if I just draw this in green, the x-axis you could see is the mirror that is standing between these two triangles as we speak in terms of a reflection. So what is the equation for the x-axis? It is where y is equal to 0. And remember, though, the fact that they said equation, you have to be very careful, right? If you say the x-axis here, you're not going to get it right because they did say an equation. So an equal sign must be between two ideas. So this is where y is equal to 0. That is what we call the x-axis, but context for your question, state the equation of the mirror line, right? So we're seeing that that is the x-axis right there. Let us now take a look at the B part, number 2. It says, describe fully the transformation which maps triangle X onto Z. So now we're looking at X onto Z, X to Z. Let us just take a look at X and Z. All right, X and Z. All right, so when you look at X, we're looking at X here onto Z. In other words, then you're seeing where it's going this direction, like that direction. You're also seeing that it's not an enlargement or a translation. It's not a reflection that takes it there. So it's a rotation. And so with the rotation, what we want to do is to tell certain things. So we know it's a rotation. We could see it's going to go based on the direction, it's going counterclockwise, right? So it's a counterclockwise rotation. All right, so we pick up that counterclockwise rotation, and we're looking at the angle of the rotation. All right, so whenever you're rotating and you move from one quadrant to the next quadrant, it's a 90 degrees already. All right, because 90 degrees go next door. 90 degrees will always just go next door, right? So that's the 90 degrees. And when we say next door, I'm referring to your quadrants. Take a look. We have 1, 2, 3, 4 quadrants. So if I'm in this quadrant and I rotate any direction 90 degrees, I'm either going to end up here or here. So we went that way. So we are in that quadrant there. So definitely that's a 90 degrees. So we need to know the center. You could look, this question is really nice. You could look and see the center. I'm going to pick these two corresponding spots here to do that. I'm looking at right here and right here. So because I know it's a rotation, I'm searching for my center. And I'm not asked to really prove it. I just want to see it. So I'm just going to identify it for you using this pink idea right here. Right here is the center. So if I should just quickly connect this point to that center and this point to that center, it's going to tell us the angle that we were referring to, which is a 90 degree. So we were saying that this is a 90 degree there. So any two corresponding points that connect to the center with a straight line, it will always show you the angle that the rotation actually took place. What angle was the rotation? So you could see there, that's a 90 degree angle right there. So let us just go and describe it here. All right, so one, the transformation is, I just say this is it's a rotation. (90 degrees) counterclockwise or anti-clockwise, if you may say, about the center 0, 0. Right? There are other things that you could say too, because you could see it as well as you can see it as a 270 going in the other direction, because 90 in one direction is 270 in the other. In other words, then, let us say that you wanted to look at it from here going that way. It would have been 90 degrees to here, another 90 here, and another 90 to come back here. So that would have been 3 90s. So bear in mind that this same thing could have been referred to as we could have called it a rotation of 270 degrees clockwise, not anti-clockwise now, clockwise, about the center 0, 0. Or you can use the word origin if you want, right? About the origin. So I'm just saying there we can describe our rotation in two ways as long as you understand what's going on, right? So 90 in one direction is 270 in the other direction. Let's keep going. All right, so the next question says here that on the same page, we want to do this translation where we'll triangle y using the vector -7, and label v. All right, so we're going to do it. So there are multiple ways you could do it. So -7, 1. All right, -7, 1. All right, so triangle y will be acted on by a translation t, which is -7, 1. Bear in mind that the top number is going to be an horizontal motion. It either move left or right. If it is negative, it's going to go to the left, positive to the right. So this is left, and this is right. And then the bottom number, if it can go up or down. If it is positive, it's going to go up. If it is negative, it's going to go down, right? So as you can see, this motion, we're going to go to the left and then go up. -7 to the left. So we can actually do arithmetic here, or we could just do some motion because I'm on the grid. So I'm just going to move because I'm on the grid. So I could just move all 3 points, 1, 2, 3. Take a look. We're going to go to the left, 7, and 1 up. 1, 2, 3, 4, 5, 6, 7 to the left, 1 up. So that point reaches here. Then I'm going to move this point here. So it is 1, 2, 3, 4, 5, 6, 7. 7 to the left, 1 up. That point reaches here. Lastly, this one, 1, 2, 3, 4, 5, 6, 7 to the left, 1 up here. So they all reach there. So you could do that if you want, right? So you could do the motion, the movement. Doesn't matter. You do it the way in which you want. So you just get a ruler and then you just connect here. Connect this. And connect this. And there you have your translation here. And I think they said to label V, so you got to put V in this. And that's your translation right there, right? So that's one way of doing it. Let's go to the next question. It says, we want to do an enlargement with the center 0, 0, scale factor 1/2. So you triangle X. So we're gonna be messing around with X and we're gonna label it W when we're done, right? Let's go for it. So triangle X, what we're gonna do. Bear in mind though, if I'm at 0, 0, this is one of the good things with enlargement. If I'm at the center 0, 0, I could use my coordinates to help me to do the enlargement. For example, these, if I write on the coordinates of them, I could just easily get them. So this coordinate here is 0, 2. This coordinate at this point is 4, 4. And this coordinate here is 6, 2. Because I'm doing an enlargement that the scale factor is 1/2, I'm going to take 1/2 of these. If I take 1/2 of these coordinates, so the scale factor multiplied by your coordinate will give you the new location. So this is going to give me 0, 1. So you can see 0, 1 is right here. And then this is going to give me 2, 2. This is going to be, the new point is going to be 2 meets 2. So 2, 2 is right here. And 1/2 of 6, 2 is going to be 3, 1. So my new coordinate is at 3 and at 1 right here. So basically, all I have to do is just to reconnect this. And I'm going to call this W. So the basic idea is that if I am at the center, or if the center is going to be my enlargement center, if 0, 0 is going to be my enlargement center, then I could manipulate the coordinates. I multiply the scale factor by the original coordinates, and it's going to give me the image. There we go.